In today's note, we're going to be looking at the area of composite shapes. So again, similar to perimeter, the formula sheet that you got in class will have all the formulas that you need for the area of your basic shapes. So what is area? Area is the amount of space a 2D object takes up. And the units of area are usually always squared. So for example, centimeters squared is represented by that to the power of 2, meters squared, feet squared, inches squared, millimeters squared. Anytime you see a unit squared, we're usually referring to area. Now, some common formulas, again, you don't have to remember these because these will always be provided to you. First, we have a square, and the area is the length times the base, or length times the width. And again, if this was a rectangle, it's basically your two sides multiplied by each other. For a triangle, we have area is equal to the base times the height divided by 2. And if we look at the first triangle, it doesn't matter how you orient it, the height and base are interchangeable. If I look at the second triangle, the height would be this kind of imaginary line going from one point down. That would be our height, and that would be our base. And if we were to change the orientation of this triangle, the base and height would change as well. For a circle, our formula is a equals pi, which is this symbol here. Pi, and pi as a number is 3.14. There are many decimals after that 4, but we'll just focus on 3.14 times radius squared. So if I have my circle, the radius is from the center out to the edge of the circle. That's my radius. You may see a circle where they give you the diameter, which is from one end to the other, all the way through your circle, and the radius is just the diameter divided by 2, or half the diameter. And again, from last note, composite shapes are just shapes that can be divided into more than one basic shape. So if I look at my first example, this is the exact same shape that we had in our last note where we looked at perimeter. So that's where I have my two other measurements that you can see written in here. If you want to refer back to that note, you can see how we got those numbers. But in this case, we're looking for the area. So what we have to do now is divide our composite shape up into as many basic shapes as we can, and then use the area formula. So looking at this shape here, I can see a rectangle here. There's one rectangle, and I can see another one here. And there's a second rectangle. So what I'm going to do, or what I need to do to find the area of this whole shape, is find the area of each individual shape and then add them up. So the area of my blue rectangle, length times width. And if I look at this shape, my length, say, is 66.8 times 36.4. And I get an area of 2,431.52. And that would be centimeters squared. And then I'm going to find the area of my second shape, or the red rectangle. Again, length times width. Here it would be 19.4 times 43.1. And I have an area of 836.14 centimeters squared. Then finally, for the area total, I just have to add area 1 plus area 2, or the two areas that I found. So 2,431.52 plus 836.14 equals equals 3,267.66 then centimeters squared. And that's the area of the entire shape. Example 2, similar shape to our last note. It looks similar to a racetrack, and if I'm breaking this up into basic shapes, you can see a rectangle here. And I can see two semicircles here. And again, what I'm going to do is find the area of each individual shape and then add them together. I'll start with an easy one, my rectangle, length times width. So in this case, 0.6 times 0.5, which is 0.3 meters squared. And now I'm going to find the area of a circle, which I need to do for my two semicircles. And that formula is pi r squared. So now I need my radius. Right? If I look at my diagram, I'm not given the radius, I'm given the diameter. And if we look back to the beginning of our note, the radius is equal to diameter divided by 2. So the radius is equal to 0.5 divided by 2. So my radius is 0.25. So I can use that number in my formula. So pi 3.14 times 0.25 squared which works out to 0.19625. And if I wanted to find the area of each individual semicircle, I could divide this number by 2. However, I would only have to multiply or add it to itself to get a full circle, which I already have again, so I don't need to do anything further to this number. Then finally, area total is equal to area 1 plus area 2, which is equal to 0.3 plus 0.19625. Oh, we forgot our units, meters squared. And we get a total area of 0.49625 meters squared. And that's our total area for the entire shape. For example 3, we have a house shape. Again, we can see our two shapes. We have our square here, and we have triangle up top. So I just need to find the area of the two shapes and add them together. I'm going to find the area of my square first. That's the easiest. So length times width, 12 times 12. My area is 144 centimeters squared. Now I'm going to focus on the area of my triangle, which is base times height divided by 2. If I look at my height, or my triangle, I know the base is 12 centimeters, but I don't have the height. Remember, the height would be this measurement here. I don't have it, and it's not 15 because 15 is a different side. What I do have though, and if I take my triangle and kind of look at it separately, the bottom is 12, or the whole bottom is 12, and the side length is 15. If I wanted to look at just half of this, 15, and half of the bottom would be 6, and I'm still looking for that height, so I can use my Pythagorean theorem formula here to find that missing leg. And if I'm looking for a leg, it's a squared equals c squared minus b squared. A squared equals c squared is my largest side, so 15 squared, minus b squared, which is 6 squared. A squared equals 225 minus 36. 189. Again, the last step, we have to square root. We get 13.75. So this is 13.75 is my height, which I can take and put into my area formula for the triangle. So 12 times 13.75, all divided by 2. 12 times 13.75, 165 divided by 2, 82.5 centimeters squared. So I have the areas of my two shapes. Now I just want to add them together to get the total area. So area 1 plus area 2. So we have 144 plus 82.5. And we have a total area of 226.5 centimeters squared. So that's the area for my entire shape. For question 4, this one's a little different because now I want to find the area of my shaded figure. So I can see my shaded figure looks like a rectangle with a triangle taken out of it. And the way you solve these types of questions are, you're probably going to have to do a subtraction. So what you want to do is you want to look for the large shape, and in this case the large shape would be our rectangle. You can see coloring in blue here. That large shape, we would want to find that area and then take out this area from that large shape, which would give us only the shaded figure. So let's start with finding the area of our rectangle because that's usually the easiest. So length times width. Which is 18 times 10. So I get 180 centimeters squared. And the area of a triangle. Base times height divided by 2. So the base I don't know, but if I look at my shape, the whole top side is 18 centimeters, and I can see on the bottom I have 6 centimeters, and then a missing part. If the whole thing has to equal 18, this missing part here would be 18 minus 6 from the one side minus 6 from the other side, which leaves me with 6. So that means that this section here is also 6 centimeters. So I have my height, it's given to me in my triangle, 5 centimeters, so 5 times 6 divided by 2. So we have 30 divided by 2, which is 15 centimeters squared. So I have my two areas. So now my total area is going to be my large shape, area 1, minus my smaller shape, area 2. So 180 minus 15 equals 165 centimeters squared. And that gives us the area of our shaded figure. And that is it for the note today.